All right, I think we're good to go. Welcome everybody to the workshop. I'm going to hand it off to Donna, I think, to introduce. Yep. Great, take it away.
So my name's Donna Ball, and I'm a senior scientist with SFEI, and we want to welcome you all here today. I'll be facilitating the workshop, kind of herding cats between the different sessions. I just want to point out we won't go through introductions. I think we have over 60 participants, so please look at the list and a participant list and see which of your colleagues are here today. So for the agenda, our goal today is basically to introduce the landscape scenario planning tool to both current as well as new users. And then we're going to be talking about scenario design, some technical aspects of using the tool. We're going to use a case study to show how the analysis and the outputs. And then we will have a time for some breakout group discussion, and after that, a Q&A session. I do want to say that each of these presentations, we have a really jam-packed agenda today. So we'll have a couple of questions after each presentation, and we're asking that you hold your questions until those question and answer sections. And if you don't get a chance to ask a question, then we will have a dedicated Q&A session, so we can save questions for there as well as the breakout groups. So I think I'll also be monitoring the chat and the hands up, so feel free to post any questions you have in there, and we'll try to get to those if we can with the time we have. So with that, I think we'll jump right into the introduction to the tool from Letitia Grenier, our SFEI ASC's Resilient Landscapes Program Director.
Hi everyone, it's so great to get to talk to you today. I'll be giving you a high-level introduction to the tool, and don't worry, there are experts coming on after me who are going to get into the details of how the tool works, and then you'll actually run through an example. So this will be pretty high-level and quick, just to help you think about what the tool can be used for, why it was created, and a general sense of what's currently been programmed into it. So essentially, the idea behind this tool was to have a simple and standardized way to have kind of like a common platform for thinking about how to plan for restoration in the Delta and creating a resilient future Delta. And so the elements of the tool are that you can construct restoration scenarios and then evaluate them according to a number of metrics that you'll be hearing about during the rest of our presentation. So essentially what the tool allows us to do is to say, okay, what do we want this landscape to do in the future? What are the functions that different people or different sectors want it to perform? What are the benefits from this landscape that we all want to have? And then we can look at different future scenarios and say, okay, what are the benefits that are derived from each of these scenarios? And the metrics are a really important determination, obviously, of what you get back. So they're very rooted in science, and I'll be going through the specific ones that have been programmed so far. But essentially, we've tried to create pretty sophisticated, customized metrics that are really grounded in the literature about if something happens on the landscape, what's the potential for that future landscape to support the desired function of interest? And I'll get into some detail about that. And then because it can operate at this big scale, it can help you understand the cumulative impacts of multiple projects. So this is one of the challenges I think we all have thinking about large scale restoration is we're trying to put back together a very big ecosystem, trying to get it to a place where it's functioning better to achieve the goals that are desired. But you have to do this, just doing one project is really hard. It takes a really long time. So how can you keep track of what all these different projects across a very big system are doing? Because the system really acts in ways that are interrelated. So, we don't want to be doing random acts of restoration. We want to be putting back together a really functional and efficient ecosystem. Next slide. Thanks, Lawrence. Okay, so one of the really useful things that you can use this tool for is helping to implement the Delta plan. So it can promote and assist with compliance with policies. So just by putting metrics in here that are related to some of the goals of the Delta plan, I think that helps people who are starting to think about how to design their restoration project to aim in a certain direction to hit a certain target. And then it's also a way to anticipate and measure the impacts of restoration and other actions on the performance measures, especially coming out of the ecosystem amendment. So before all the investment has been made and all the processes have happened that have to get to the actual restoration on the ground, you can anticipate and think about what's the trajectory of the landscape toward the goals. Next slide. I keep trying to advance my own slides. Thanks, Lawrence. This is also helpful for evaluating proposals. So thinking about, where should we spend the money in the Delta? One of the things to think about is how are all these pieces going to fit together? How are all these different projects and actions going to help build toward the desired goals? And that's what these metrics can help do. Next slide. And then it can actually help you track the projects themselves. So we all have an idea of what we want to achieve when we start a certain project. Sometimes things change. So you can actually use this tool to measure what actually happened after the project was implemented. Did it progress in the way it was expected to? Is it performing as expected? Next slide. So the landscape scenario planning tool is built on a lot of the work that we at SFEI ASC did over the past decade or so, trying to understand the Delta historically, the processes and patterns that happen on landscape, both biologically and physically, what the Delta is today in terms of landscape and what it could be in the future. And there's a series of 3 reports there on the left where we worked on that. And so some of the things that I think were really valuable about our approach was that it was very large scale. Again, we were thinking about the system scale of the Delta. And we were focused on process-based restoration. So how did the natural processes function historically, and how could that help us think about what could be achieved on the landscape in the future? How do those natural processes support ecosystem functions? So it's very much based on that kind of philosophy, and we really thought about this holistically. This is not a solely fish-focused project. It's holistic, thinking about all the different habitats in the Delta, all the different guilds of species that might want to use them. What are the benefits to people? And then certainly, and of course, recognizing that, I call the Delta a system, but it's just the middle of a very big system with a huge upstream and a huge down estuary. And so making sure that we're thinking about the connections to the larger watershed. So we hope that this approach helps us to think large scale and long term, and that we can use this information to inform future decisions. And sometimes people ask us, why do you look at the past to help think about the future? And in a place like the Delta, I think we can understand really clearly why. It's so altered that if you just looked at the Delta of today, you wouldn't understand the place that was formed via the natural processes here. And that place was where many of the wildlife species, and pretty much all of them that people want to conserve or are concerned about the recovery, that's where they evolved. And that's the system in which their life cycles are, and their body design is essentially made to go with that system. And so we have to have that template and that understanding, both to understand what physically could happen in the landscape into the future and what biologically could happen to support species of interest. Really important, especially in terms of big changes that could happen, such as climate change that is happening and the earthquake that we are told is going to happen sometime. Next slide. So what is this tool and how does it work? Lawrence is going to get into this in a lot more detail shortly after me, but basically you can put different landscape scenarios into the tool. It's completely spatial. So these are GIS data sets. Put those into the tool. The tool analyzes them relative to these metrics that I've been talking about, and they're things like, how much would this scenario support marsh wildlife? How much would this scenario support fish? How much would this scenario affect agriculture? I'll go through that list in a minute. And then it's going to output those results so that you can compare the scenarios next to each other. Thanks, Lawrence. Next slide. Okay, and so there's a bunch of different ways that the outputs are visualized. There's maps, there's charts, and you're going to go through this again in detail with an example from Frank's tract in a little bit in the future. But for now, as I click through these, I'll be showing you comparisons of the historical Delta, the current Delta, and then a couple of future scenarios. Next slide. So the idea is that this puts in the hands of the planner or the restoration practitioner or the person who's thinking about designing a future project a way to really quickly and easily compare some different options and think about, it could be like, I own this island, what are the different things I could do with it? It could be, I'm funding this Prop 1 grant, what are the different portfolio of projects that I want to put together? And so one of the ways that you'll see this is in these tables, and Lawrence will get into this, but there's ways that we've tried to mark so that you can look really quickly visually to see if we think the scenario improves that function for the Delta or negatively affects that function. And so what's really important here to note is that the metrics that are programmed into the tool really matter, And the way I think of this is everybody can have a seat at the table if your metric is programmed in here. So if you're really interested and you're only interested in salmon, there needs to be a few salmon metrics in the tool if you want to be represented in the thinking around what's going to happen with the future delta. And so what we're working on now, and I'll talk about this in a minute, is making sure that there are more metrics included here so that we're starting to represent more of what people really value out of the delta. What are the functions they really want this landscape to do? Next slide. Okay, so here's an example looking at the marsh habitat metric. And what you can see is there's many different aspects of marsh habitat. Again, these are very grounded in the literature. And then we compare, how did that metric measure historically? How does it measure now? That's the historical and modern bars. And then the orange bar is looking at what the Eco-Restore suite of projects would do. And you can see that for some of these metrics, the Eco-Restore scenario really moves the needle on improving the situation. Next slide. And like I said, we try to have these be very customized, very based in the best available science. So it's not just, we do have, how many acres of this habitat is there? But for patch size, for example, we try to provide thresholds that are biologically meaningful. So for example, here you can see that the largest patch size is 4,500 hectares, and these circles down on the bottom right. And that's the average historical patch size. We're not suggesting that we're going to get back to that, but what we are showing is that for 500 hectare patch size, you get a full channel of networks in your marsh. So you have a big enough marsh space that you get really good drainage going in and out. And we know that those channels are what brings in biota and sediment and causes the exchange of things that really make marshes valuable, especially in terms of feeding fish or in terms of exporting food. And so that's a really important threshold, and that's what we'd include in the tool to try to, again, kind of aim people towards something that we think provides the most ecological function based on the literature. And then there are these smaller patch size, and we point out the amount of function that those provide for black rails, which is a marsh bird, so that you can kind of get a sense of what range your project is in and what kind of function you might get from it. Next slide. Okay, and there's several of these. I'm going to go through these really quickly because you're going to see them in more detail in the upcoming, but just to give you a flavor of what the different kinds of metrics that are in here are. We started with a lot of ecological function metrics in terms of supporting different guilds of wildlife. So there's one about supporting woody riparian habitat. Next slide. And another about fish, and that one has a variety of work behind it, and it's pretty nice and holistic. So you'll be able to see that for the Franks tract. I think April is going to give you a clearer description of this. Next slide. And so I don't want to steal your thunder, April, but there's different ways that we can think about supporting fish in terms of the different aspect of their life history that large wetlands and other wetland habitat provide them. Next slide. Next slide, Lawrence. Thanks. We can also look at physical parameters on the land, for example, how much subsided area there is, so that we can start to think about sustainability in the future delta. So thinking about, okay, if I put back different kinds of land use that keep the land more wetted, how would that affect the situation that we have with subsidence, which of course affects a lot of different issues, both financially and in terms of ecological and water supply issues. Next slide. And then we also are trying to build in more now about agriculture. So what's in there right now is how much agriculture would be impacted by the proposed restoration projects. And I want to say that the suite of eco-restore projects, if I remember correctly, impacts 2% of the agriculture in the Delta. So it'd be a conversion of 2% of the agriculture to more natural habitat types. So that starts to give you a sense of the magnitude of the impact of restoration on the agricultural economy. Next slide. And you can see, you can also break it down into which crop types were affected. That's what that graph was showing. Next slide. You can also look at infrastructure. I always think of the Delta as being, kind of rural and not having a lot of infrastructure, but there's all kinds of things going on often underground that really impact restoration projects. So this is really helpful to think about what are the different kinds of infrastructure that intersect with the project area of interest. Next slide. And then you can also look at what are the land ownership and land management types. So that helps you think about what kind of land is getting converted. And for a lot of the eco-restore projects, they're working with public land. And so that's helpful to get a sense of what kinds of lands are in the footprint of restoration. Next slide. So right now we're funded to put some new modules or metrics into the tool. So we have a team working on carbon and greenhouse gases. It also has elevation. So that'll really help us start looking toward both sustainability in terms of elevation and levee maintenance costs and things like that, but also that will help with some future work on trying to get some monetary estimate of what future scenarios could do in the carbon markets. We're also working on economics. Again, this is getting back to agriculture and also recreation. So trying to more fully build out some of the other desired functions of the Delta. And then we're working on also expanding this. The footprint that we have currently is most of the legal Delta, but we're expanding it to include the full legal Delta and then also Sassoon. So then we'd be covering kind of the whole area that the Delta Stewardship Council is working on.
You have about 4 minutes, Letitia.
Say it again, Donna?
4 minutes, and that includes our question time.
Gotcha. I'm just about done. Thanks a lot. And then tracking landscape change. So VegCamp has been updated. We're bringing that updated data set into the tool, integrating it with EcoAtlas, which is a tool that's widely used in the Bay and in other areas. And that's helpful also for tracking projects. And then we're also doing a lot of outreach. Next slide. And with that, I will take a couple questions if there's still time, Donna, before I turn it over to Lawrence.
Yeah, we probably have time for maybe 2 questions, but we have about 3 minutes. So. I'm not seeing any. And feel free, you can put questions in the chat, or you can just pipe up and ask Letitia directly. And if there's no questions, then we'll let Lawrence go ahead and start on scenario design.
All right, then.
I have.
Oh,
go
ahead.
Am I too late?
Now we can hear you.
I'm kind of curious. Can you hear me?
Yes.
Oh, Letitia, I'm curious how you would make this available to project proponents. Probably on a fee basis, I imagine, but that probably takes a lot of time to run the models, and then you prepare all these nice reports. I'm just curious how it would be offered.
Yeah, I'll offer you the high-level answer. Lawrence, you can jump in if I get anything wrong. But right now, so kind of yes and no. It's completely free and available for download right now. Anyone can download the tool and run it themselves, but you do need to have ArcGIS and some expertise to be able to do that. So that's the trade-off. The reports are fully automated. All the programming has been done, and there's no fee. But it isn't as easy as something on like a website where you can just go and toggle a few things and get a report. You actually have to have the ability to build your own scenario, which Lawrence is going to talk about, and then run it through Arc yourself.
Yep, ArcGIS, and then within that, to be specific, spatial analyst is required for some of the raster processes. At current, the advanced license is necessary for 2 of the tools we run, but one of the improvements is to figure out ways, if you don't have the advanced license, to bypass that through some other tools that maybe do the same thing.
Does that get at your question, Steve?
Yes, totally. I don't know if you mean, Lawrence, open source tools or what, but that was a great answer. Thank you.
I just saw really quickly in the chat, it is for ArcMap at current. One of the main priorities code-wise is to port it for ArcPro. So it's going to be one of the first things we improve on.
Great, thanks. We'll go. I think we're able to move on, Lawrence.
Cool. Okay, so scenario design. In a very technical sense, scenarios are just polygons of habitat that are burned on top of the modern layer. So as this graphic kind of shows you, you create some polygons of habitat type, and they just kind of replace on top of what they were overlaying on the modern. Each polygon should have a habitat type that's recognized by the tool. Maybe we'll get into that a little bit more later, but there's a crosswalk table. It's all in the user guide, which habitat types are recognized. And then each polygon represents some sort of land use modification, whether that's restoration activity or what have you. The idea is that these scenarios are evaluated for change on a landscape scale. So you could just be looking at one project, or like the Eco Restore example we ran previously, it could be looking at a suite of different restoration efforts and how they interact with each other, not just the improvements they do individually, but in sync. And the tool, the DLSPT, is generally focused towards these ecological functions identified on the bottom strip here with a little brief introduction or brief description. All right, so just kind of getting into a real technical sense, how do you create scenario overlays? One of the simplest method would be, if that data already exists, even better if it's already a spatial layer, you just use that. You just have to give it the right attributes for the habitat type. But that's more or less, yeah, just copying it in. Another way you can create these, or you can edit. So you can take existing habitat type polygons from the modern layer, which depict how they currently exist, copy it into your overlay layer, and then just kind of play with that polygon, edit, modify, expand or shrink the boundaries as the restoration activity would affect them. And of course, you can just also freehand it. You could either just draw new polygons, or this could be tracing it from a blueprint or something like that. I mean, these are just the basic ideas, but basically any sort of GIS tool where you can manipulate polygons. Aside from that, we've also provided some layers to help you design scenarios, packaged with the tool. Not used in the tool, but for guidance in developing these scenarios are 4 landscape potential layers that give you ideas where there are potential restoration opportunities. You can copy these in as well, or use these to guide where the limits of maybe the restoration could expand to. In addition to these, which we have a web online web map atlas sort of thing. It's the URL is up here, deltaplanningmap.sfei.org. It's also linked on the project page, so you can get there from the main project website as well. And this contains those original 4 landscape potential layers, but a lot more. We have, if you go through the data catalog on there, it'll show you opportunities by habitat type potential, and these will be further split into subcategories with just the main opportunities, breaking out into more specific ecological functions, any other layers that are related to that habitat type potential, and of course, supporting resources, which is just all the other layers that aren't directly related, but are very helpful in creating scenarios, from agriculture layers, DEMs, all the infrastructure layers. There's a ton of layers in this tool, so this is a great resource for just being able to see anything that might affect how you plan your scenario overlay. The next thing, the only other thing you really need for the input, and this is optional, is the levee network. Just not going to go into huge amount of detail, but basically one difference is you provide the entire final levee network, not just the added and changed. You want the final desired configuration. If it's not provided, it's just assumed that there's no change from modern. Where this comes into play, the simplest is in the infrastructure module, obviously just seeing where levees have been added and removed and just getting that raw metric of length. But where also comes into play, maybe more importantly, is in the fish module. So levees are levees are assumed to disconnect water. And in the fish module, it's many of the analyses hinge on connected open water. So the levees are important there to disconnect certain channels if they are blocking it. A couple other considerations. There are a few topology checks built into the tool, but it's definitely not comprehensive. One of the more important ones that you want to be aware of is overlapping polygons. So if you have overlapping polygons, it may be handled a little differently in some analyses, but you run the risk of double counting. That overlapped area will be double counted in the area. Levies, as I mentioned, you provide the whole final levy configuration, and then the tool compares it against the modern to see where the changes are. This means a small offset in a levy position, even if it's just some sort of map error or what have you, will be interpreted as that entire levy being removed and then a new one being constructed just beside the old one. So because of this, it's generally better to work with the provided levy layer, the modern levy configuration, and then make your changes to that just to avoid any sort of these small offset errors. Oh yeah, and then one way you can check sort of the feasibility of the scenarios that you've created is the physical suitability module. We'll go over this in more detail later. This is something you won't see until you run the tool, and it's part of the outputs. But once you see this output, it can give you an idea about the physical suitability of the scenario overlay polygons that you drew. So you see yellow flags and red flags. You know, the red doesn't necessarily mean it's impossible. It just means that it may take heavier effort to modify that landscape to make this feasible. And this is mostly based on elevation and tidal datums. So for example here, we'll get into Frank's track a little bit more in detail, but this is just showing some of the wetlands being created are being marked as red just because given the elevation and the wetland type being specified there, it's just going to take heavier landscape modification to create that. A couple advanced options. I'm not going to go into too much detail, but it's good to know these exist. As I mentioned, there's a predefined list of habitat types that are recognized by the tool. And if you provide overlays with a habitat type that's not recognized, it will spit out an error just because the analyses won't handle that habitat type correctly. So generally, you just want to go over your habitat type list and either crosswalk it or modify it to be part of the accepted list. But there is a CSV table this is based off of, and you can go in there and add your new habitat types. It's basically just adding a new row and then checking the columns for the general habitat type grouping that it belongs to. You know, for example, you know, if it's a terrestrial type, you'll put a check in that column. Just a little. The one warning here is there's a few things that are hard coded, which includes the summary tables and the delta targets for the habitat types. Additionally, almost all the input layers are packaged with the tool for ease of use. So, you know, I went over the scenario overlays and the levy layer. But all the other stuff like agriculture layers, infrastructure, you know, all these things are packaged with the tool, and those inputs are handled internally just to simplify things. You can modify this by going in the code. If you're comfortable with Python, and it's not even necessarily scripting, it's just some variables and file paths that you want to update for running the tool. But modify it at your own risk. Some of these are pretty dynamically handled, so it could handle swapping out a layer, or it even has a variable for the field name. Some of them are a little bit more hard-coded, so changing it may break the tool. And yeah, I think that about covers the scenario design before we step briefly into the tool demo, but I'm happy to take any questions.
That's perfect, Lawrence. You have about 5 minutes for questions. And Lawrence didn't introduce himself, so I will. He's our amazing geospatial software engineer who is putting all the behind-the-scenes work on this project. So we'll have about 5 minutes for questions. Susan, I think, has her hand up.
Hi, yes, can you hear me?
Yes.
Hi, Lawrence. I am wondering how one would look at trade-offs between different habitat types. So for example, if I optimize for sandhill crane and put those sorts of objectives in, how would I see the effects of that optimization on delta smelt habitat or giant garter snake habitat? Or
Maybe some other people can chime in, but as you go through the modules, each module is generally tuned to something a little specific. So it may show an improvement in one module and perhaps maybe not reduction, but not as much of an improvement in another. Additionally, as we'll kind of get into when we show some of the outputs, you can compare multiple scenarios. So you can compare alternative scenarios that are similar, but different alternatives, and see how they compare against each other.
Yeah,
okay,
I just want to chime in. That's exactly right. We don't have those exact functions programmed right now. We do have the fish support one, but anytime you're having a trade-off, what you're going to see is, essentially scenario A, you get a much better value for fish, like in your example. In scenario B, you get a much lower value for fish, but a higher value for cranes. We don't actually have a crane module in there right now, but if we did. So you're going to be able to put those trade-offs side by side in those charts that I was showing and that you'll see April show. So you can actually visually kind of line up, okay, this one gives me more of A, B, and C, and this one gives me more of D, E, and F. And then that helps you, I think, set up for the conversation that you're going to have with the different sectors around the table of how do we deal with the trade-offs. It's, it kind of, it sets up the menu, but it doesn't give you the answer of what you should do.
Thank you. That's great.
And then Catherine Hickey in the chat has a question. If you add a new habitat type row, what values for the different targets would be assigned?
So this is one of those things where we left in these advanced options, but they're not necessarily fully, it doesn't necessarily affect everything. So what's happening here is that when you add that new row, the column where you check the grouping, for example, if you checked it as riparian, the riparian module, it doesn't know what the habitat type is exactly, but it knows to treat it like a riparian, and it gets factored in the analysis. So the thing is, for the summary table and the delta targets, they're a little bit more hard-coded. It's looking for the specific habitat names. So there is another table for the delta targets, which theoretically you can modify and adjust that as well. But generally speaking, what happens is a new habitat type for the summary table or the delta targets, it just doesn't know how to handle it. So it's not currently put into any of the categories.
I think we probably have time for one more question, if anyone has one.
I'm sorry. I'm sorry.
Susan, did you have another question? Is your hand still up from before?
I'm sorry. I often forget to lower my hand. Sorry about that.
It's good. You can have more than one question too. Well, Lawrence, I think we've given you a brief break. We'll send you back into the next presentation then.
Sounds good. So we're gonna step into the tool demo. But before, just a couple slides with a couple core concepts and a little bit of an intro to something that'll be clear later. So first of all, it's just the idea of a workspace. The tool works with what we're calling these workspaces. It's a single directory with file geodatabase and a log file within it. It's best to think of this as a project folder. Everything the tool needs will be thrown into that tool folder, and all the intermediary files, and the tool handles all the files within it, the naming system and all that. The reason we do it this way is because the workspace directories itself can be an input parameter, so it simplifies everything. So when you run, we call this the toolbox has several tools. So when you run different tools, you just point it at the workspace directory, and the tool can automatically look into that and figure out all the parameters it needs to from that kind of project you have running, instead of you having to re-point to all the parameters that are specific to said project. The one potential downside to this is you don't want to edit it because it's kind of looking for these file name formats. So if you delete something or change the name of something in it, it could break the tool, or it could break the workspace so that it wouldn't run in the tool anymore. But you can still look inside of it, of course. You can copy layers out. And there's also an, if you actually need to share it with somebody, the output tool actually does handle copying all the relevant data layers inside the workspace out into something you can share and edit a little more easily. So a quick little overview. So the tool demo will go through this a little bit more. So don't worry if it doesn't make sense initially, but there's 4 tools, and they all kind of work through the workspace, as you can see here. So the prepare workspace is the first tool, and that's just to set up the workspace. It creates the historical and modern layers by default. Doesn't do a whole lot else besides that. But once you have your workspace set up, the next step is adding scenarios. So you run that scenario tool as many times as you need to. And each time you run it, you're adding your custom scenario. And then the next step is running the analyses. So you pick and choose your analyses, and it'll run the analyses on the workspace and every scenario it finds inside of it. These are what you can kind of consider the core setup tools, and then the final is the output tool. I'll go over more specifically what the output tool looks like. I think the main takeaway to remember here is that when you're working on the workspace, it works on the whole extent. And when you use the output tool, you specify an area of analysis or an ROI, and you can kind of think of it as like a cookie cutter. It's just kind of examining the little piece that you want to look at. So when you want to look at a different ROI, for example, you only have to rerun the final tool here with a different ROI. You don't have to rerun all these initial steps. And then, so some of you who are familiar with the Delta Landscape Scenario Planning tool or have seen some of the presentations before know we used EcoRestore a lot. Just to move to something a little bit newer and different, which also has some advantages, especially in comparing different scenarios against each other. We're doing the Frank's Tracked Futures. I'm just going to do a real brief introduction on what it is. I'm not trying to get too much in depth, but the Frank's Tracked Futures. So this is a Google Maps of Frank's Track, sunken island or flooded island, and it's an area where there's a lot of effort into looking at restoration modifications. So without getting into all the background, because it's a longer story that I'm presenting, the Frank's Tracked Future was an effort that I think recently just finished up, designing a preferred landscape redesign concept. It went through a lot of phases, but it kind of narrowed it down to these 3 that it looked at. Down here below, which we're calling scenario A, scenario B, scenario C, or concept. So this was developed by the California Department of Fish and Wildlife, Parks and Rec, Water Resources, a lot of consultation with various environmental consultants, and UC Davis. And UC Davis in particular, Brett and Alejo, was very helpful in sending us the data for us to run. So yeah, basically we're gonna run it on Frank's Tracked Futures, even though this project has ended, but just to give you an idea, because this is a really good example of alternative scenarios that we can look at and how they compare against each other. All right, so I think let me unshare this for a second.
And you have about 5 minutes left, Lawrence.
Oh, okay. A little longer than I. GO2, okay. So I'll go a little bit quicker on this. This is the Delta Landscape Scenario tool being highlighted here. And these are, if you're familiar with Arc Toolbox, these are the 4 tools that you're running. I've created some examples. So these are workspaces, how they would look like after running said tool. Prepare workspace, you're just putting in your output location, folder name, and a spatial reference to enforce. And when you run this tool, you get this workspace. And you don't need to know everything in here, but you can just see that it prepped the historical modern habitats and these full kind of feature data set folders with some things in there related to that. The next tool you would add is your run as add scenarios. So you start with the workspace directory. You add your internal file name, which is important because there's some file name restrictions for the internal names, but you can also do the display name alias that'll be used in text and outputs. You add your scenario overlay over here, and once that's filled in, you select the attribute field that represents the habitat type. And the levee centerline layer is the last one. As you can see, it's optional. There's a little bit of a warning here, but you can run it without. It just says it will assume no changes. Once you ran all the scenarios, this is what the workspace looks like. You can see, so this is the internal name I use, SEN-A, SEN-B, SEN-C, and it's created the scenario data within there. The next tool is run analyses. So you pointed out your workspace again, and you select one or more of the analyses you want to run, or maybe all of them. When you run that tool, after the workspace is going to look very complicated, but that's just all the data that's related to the analyses. So you don't need to know what all this is, but just kind of showing you how that workspace has grown. The final step is to output statistics. So in this one, you'd select your workspace directory. It'll show your scenario names that you want to output. You can select all, but if you want to just examine one, you can just leave it at 1. Your area of analysis, which can be custom or one of these predefined ones, and the output folder. So just really quickly what that output folder looks like. It'll create 2 folders, one called output, and the subfolders in there you have your CSVs, table data with all these metrics, map documents, these MXDs, and shapefiles and rasters. A lot of shapefiles and rasters for this one. The other important one is this results, the report page, and this is a web page, but you don't need, and you view it in your browser, but you don't need to be online. So you can just open that up and look at it. And April will go over this in the next section in much more detail, so don't worry about it too much. But you can just see how it's kind of dynamic. You can look through different modules. There's charts and graphs and maps, and you can also print this report as a PDF. Okay, so in the interest of time, I think that is good. And then let me move us back to the slides.
And so maybe one burning question in between presentations, and do feel free to get up and stretch. We're not taking any breaks, so if you need to do jumping jacks for this highly technical presentation, feel free. I don't see questions. So given no questions for this section, we will have another opportunity during Q&A if, as you're kind of digesting all of this and want to ask questions towards the end, feel free to save them for that period too. So April, I guess you're up next.
Thanks, Donna. So hi, everyone. I'm April Robinson, an environmental scientist with the San Francisco Estuary Institute. I worked on the Delta Landscapes project that some of this tool work is based on, and have been working on the tool as well. And as Lawrence said, I'm going to go over some of the output from our running the Frank's Track futures through our landscape scenario planning tool to show you what that output looks like, talk a little bit about what those results are, and how that shows ways that the tool can be used. Thanks, Lawrence. So I think probably a lot of you are familiar with Frank's Tract, but just in case anybody isn't, it's a flooded island that's in the central delta. Lawrence, I don't know if you can put your cursor on it, but it's that. Thank you. It's that circle there in the middle. It's surrounded by a lot of publicly owned lands there in yellow, and that map is also showing some other restoration projects happening in the delta. But just some important context about Frank's Tract. It's publicly owned state recreation area that's very popular for fishing and for recreation. It's relatively shallow in its subsidence relative to some of the other islands in the central delta, which makes it very appealing for thinking about tidal marsh restoration. Next slide. Thanks. Okay, so in order to run the scenario or run the tool on these scenarios, we first had to input them into the tool. This is what they look like, those three scenarios as reflected by the habitat types that are in our tool. So you can see the dark blue there is open water, the teal is tidal marsh, and the dark green is willow riparian shrub scrub. We've entered those three scenarios into the tool, and then that dark black line there is showing our area of analysis. So as Lawrence said, you have the option as the user to define what your area of analysis will be and what you want to look at in terms of the area that the metrics analyze. Next slide. Okay, so this is looking at our area of analysis just for this example. And we wanted to choose an area that was a little bit bigger than just the Frank's Tract Island itself so that we could put the results of this analysis into context. So you can see some of the islands surrounding Frank's Tract there in the middle. That blue open water area is surrounded by islands that are either agriculture, shown there in pink, or grasslands with a mix of other habitats. And there's also notably a lot of remnant tidal marsh islands nearby. So there is existing tidal marsh habitat that the habitat that's created can connect to. Next slide. Okay, so as Letitia set up and as Lawrence talked about, there are different modules for the tool, and they each relate to different functions or benefits that we're interested in for the Delta overall. So I'm just going to walk through each of these different modules to give you a sense of the type of output that we have. There is a lot of output in each of these modules. There's a lot of text and maps and graphs and tables. And I won't be able to show you everything in this, but just wanted to give you a sense of the types of analyses that is covered and what it shows us about these different scenarios. Next slide. So to start with, the first module is the summary, and this kind of rolls up all the other modules so that we have a big table of the different metrics. And for each of those metrics, we show whether the scenario is positively or negatively affected the different metrics. And we've starred the ones that indicate the best conditions for that metric. And we really think this module is useful for getting a snapshot of understanding what's happening across those different metrics. So getting at those trade-offs and those benefits for different scenarios. But just looking at the summary table itself doesn't give you a lot of context. So it is really important to also drill down to the individual modules to get the kind of explanation and supporting details to understand what's happening with each of those metrics. Next slide. Okay, so the next module is the habitat types. And this is kind of a basic module that underpins a lot of the other metrics that we look at. The habitat types that we use for the tool are based on the habitat types that we used in the Delta landscapes work, looking at the historical and landscape change in the Delta, looking at vegetation, aquatic features, and land use. And those are really important classifications that get at a lot of the functions you'll be able to support and also connect to the Delta plan acreage target. Next slide. So looking at our the output for our different scenarios for Frank's Tract, the biggest changes that we see with these are the increase in tidal freshwater emergent wetlands and the increase in willow riparian shrub scrub. I'm just showing just a bit of the overall table, which is quite a bit longer. For both of those two major habitat types, scenario C adds the most, but all three of those scenarios are adding a significant amount of the different habitat types. And we can also look at the amount of habitat being added relative to the Delta Plan targets to see that for these scenarios, we're achieving between 3.2 and 3.5% of the Delta Plan targets. Next slide. Okay, and then we wanted to drill down into some of the specific habitat types, looking first at tidal marsh and the ability to support wildlife that's associated with tidal freshwater emergent wetlands. And we look at tidal marsh in a few different ways, thinking about marsh patch size, marsh connectivity, marsh patch shape. And in order to do that, there are rules in the tool that help us figure out what we consider a marsh patch. And that has to do, as Letitia said, it's very grounded in the relevant science to look at thresholds that relate to different wildlife species in the Delta to get at what's considered a patch. And you can see there showing the historical, modern, and one of our scenarios of the different colors representing the different patch types. That historically this Frank's Tract was part of one large patch, and today we just have a lot of much smaller marsh fragments. Next slide. Okay, and so for these three scenarios, you can see that one of the exciting things about these scenarios is that they're all adding at least one large marsh patch type, or sorry, at least one large marsh patch, by which we mean a marsh that's at least 100 hectares, which is important for supporting high densities of black rails among other wildlife species. And I think some really important context for that is understanding that currently in the Delta, we only have 3 marsh patches in the whole Delta that are greater than 100 hectares. So it really is a very meaningful thing to be adding either 1 or 2 additional large marsh patches that are greater than 100 hectares. So scenario C gives us 2 new marsh patches that are large versus 1 for either scenarios A or B. Just to point out though, none of those scenarios are giving us marsh patches types that are greater than 500 hectares. So it's still quite a bit less support in terms of marsh patch size than what we had historically. Next slide. Okay, and just some other ways to look at marsh patch size too. Again, there's a lot of different ways of parsing the different marsh configurations. And for most of these, scenario C was slightly better than the other 2 scenarios. But again, all of them are really increasing conditions compared to what we have right now. Next slide. Okay, we also wanted to look at wetland connectivity for the marshes. It's an important part of wildlife dispersal and gene flow and supporting resilient populations. We looked at that a number of different ways by doing nearest neighbor distance, some network analysis, and some stepping stone analyses. And I don't have time to go through all of those analyses right now, but just to walk through one of them. Next slide. Next slide, Lawrence. We wanted to look at the distance between or how far each of our marsh patches are from the nearest large marsh patch. Thinking of large marsh patches as those areas that are most likely to support high densities of wildlife and the ability of wildlife to disperse from those patches. And we wanted to compare that distance between marshes to the average distance that a black rail might disperse. And you can see that right now, the distance between patches is about 13 kilometers, and the average distance that a black rail disperses is 5.6 kilometers. So that the distance between patches is greater than the average dispersal distance for black rails. So not great for supporting that species dispersal. And you can see that all 3 of our scenarios would increase connectivity in a way that allowed these patches to be within the dispersal distance of black rails. So still quite a bit higher than the historical connectivity, but a meaningful improvement in terms of the function of supporting dispersal of marsh wildlife. And again, here's another example where all the scenarios are improving conditions, but scenario C is improving conditions the most. Next slide. Okay, and then we also wanted to look at marsh patch shape to think about whether or not we just had a lot of long, skinny fringing marshes or more wider habitat with less edge. And that marsh patch shape is important for supporting habitat complexity and helping to determine the amount of edge effects we have or the susceptibilities to some of the stressors that happen along the edge of habitat patches. So all of the scenarios are increasing the core to edge ratio. You can see that teal color is representing the core of the marsh and the orange is the edge there. So we're getting more core area, a relatively similar amount for all of our scenarios, but again, the most in scenario C and quite a bit less than we had historically. Next slide. Okay, so moving on to woody riparian habitat and the support for riparian associated wildlife. So this is an interesting case in that historically there really wasn't any riparian habitat in this area. You can see in the chart there, the missing green bar is meant to be the historical, but we do have a fair amount of riparian habitat today. And riparian habitat is important for supporting a lot of species that we care about in the Delta overall. And can support getting us towards our Delta Plan targets for riparian habitat. So scenario C increases the overall extent of riparian habitat the most, but scenario A would give us the largest size riparian patches, with larger sizes having the potential to support more species and greater population sizes. Next slide. Okay, we also wanted to look at wetland buffer to think about those areas that are adjacent to wetland and aquatic areas that can be important for providing buffers to stressors or for providing additional habitat or areas of refuge under high water conditions. And we have been looking at buffer in terms of more natural habitat covers versus more developed, highly modified areas. And all of their scenarios are adding a fair amount of natural terrestrial buffer habitat. It's really being provided by those riparian areas that we just talked about. They're all providing relatively similar amounts, with again scenario C adding just a little bit more than the other two. Next slide. Okay, then we have our module looking at support for fish in the Delta. And there's a lot of different ways that fish are supported by the wetland, riparian, and aquatic features in the Delta. So we've already covered some metrics that are going to be important to fish with the other modules we just looked at with marsh and riparian habitat. But we also wanted to add some additional metrics that specifically looked at things that we think are important for supporting fish. Those include marsh to open water ratio, the connectivity of large wetlands along migration corridors, vegetated channel edge, and water temperature. I'm not going to have time to get into the details of all of those. You can see here, looking at the marsh to open water ratio, that we're really thinking about the Delta as a place that historically was dominated by marsh. So a lot of the open water areas were really influenced by that marsh, by that high degree of marsh relative to the open water. And today we have quite a bit less of that. But all three of our scenarios, again, are going to improve conditions. Next slide. Okay, and then just to go through one more of the metrics that we have for fish support, we wanted to look at connectivity along potential migration corridors for salmon and think about where our large wetlands are situated. We know that large wetlands have the potential to provide food and other resources for salmon and for other species that are passing through the Delta, particularly those larger wetlands that can support dendritic channel networks. So we wanted to think about how much distance there was in between those large wetland areas relative to how much salmon, fry, and smolts might move in a day. So tying that to thresholds of fry are moving on average 2 kilometers a day and smolts on average 15 kilometers a day. And in the current Franks Tract area, neither fry nor smolt are likely to encounter a wetland within a day's journey. And for all of our scenarios, we've improved that to where all of the fish are within, are less than 15 kilometers away. So less than a smolt's day's journey away from a large wetland. So a meaningful increase in the connectivity of wetlands for fish overall in the Delta. And I think going back to our first slide, that points to the importance of the location of Frank's Tract and doing restoration in this area overall in the context of our larger regional goals. So just summarizing where we were at with our fish metrics, scenario C had the greatest marsh to open water ratio. Scenario B had the greatest extent of vegetated channel edge. Scenario C had that greatest increase in the connectivity among large wetlands along the migration corridor. And scenario A had the least amount of wetlands that were being restored in areas where water temperatures were high enough to be of concern for fish. And that's based on modeled temperature data. Next slide. Okay, and then I want to move on to some other modules. So our inundation module looks at the extent of hydrologically connected and regularly inundated areas. And this is a module that's specifically meant to connect to performance measures in the Delta Plan. We aren't able to estimate changes in hydrologically connected areas relative to seasonal or fluvial inundation because there isn't hydrologic modeling as part of this tool. But what we can say is based on the habitat types that are being created, what we think the change in tidally connected and inundated areas is going to be. And for this, scenario C is again slightly higher because of the slightly higher amount of tidal marsh being created. Next slide. Okay, and then looking at subsidence, we want to look at the current extent of subsided lands that are in our area of analysis, the extent of subsidence halting land uses, so the types of maybe wetland restoration or other actions keeping water on the land that might reduce the amount of subsidence that's happening, and the approximate time it would take to reach sea level with sort of subsidence reversal projects, as they're called. We're currently doing that kind of analysis for levied areas only. So Frank's Tract isn't really considered in there. So our scenarios aren't going to alter subsidence in this case, but I think you can see from some of the surrounding islands, there is a lot of subsided land already within our area of analysis. Next slide. Okay, tool also looks at agriculture, looking at the extent of agriculture, the crop type, the type of farmland, and how much of that, again, subsidence halting land use we have. For these particular scenarios, there's no actual change to agriculture happening. There are some small changes that show up in the metrics just due to some mapping artifacts that Lawrence is pointing out there. I think this is a reason why it's important to make sure you're looking at the modules and drilling down from that summary table, because looking at these maps shows pretty clearly that those are just artifacts. Next slide. Okay, and then looking at infrastructure, there's a lot of potential infrastructure in the Delta that could be impacted. We want to look at roads and railways, energy infrastructure, and water divisions. Looking here, the example here shown here is roads and rails. There's no rails in our area of analysis, but there are quite a few roads. None of them are in areas where they would be impacted by the restoration actions in this scenario, though. Next slide. For water diversions, we look at water diversions that are within a kilometer of the proposed restoration actions because we think those might have the potential to affect the water diversions. So here there are there are 20 water diversions that are close enough that they could potentially be impacted. So we're flagging those as a potential impact, and that's going to be the same across all three scenarios. Next slide.
We have about 5 minutes, April.
Thanks. And then the next thing we wanted to look at was protected areas. So we wanted to look at land use or protected lands and land ownership. And you can see that in our scenario, all of the land use modifications that are being suggested are occurring on publicly owned land that's owned by the Department of Parks and Recs. And that's important for a lot of folks who want to see restoration happening on public lands first, and also for thinking about the protection of those restored areas. Next slide. Okay, and then finally we have a physical suitability module that looks at whether the actions are appropriate for the particular position in the landscape where we're suggesting them. So factors that would influence that are elevation, degree of tidal or fluvial influence, salinity, soil type, effects of climate change. There's lots of potential things that could impact that. Right now, most of the things we're flagging for relate to elevation and whether or not the habitat type is appropriate for the existing elevation. Next slide. So as Lawrence already pointed out, we are getting flags when we run these scenarios for our tidal and riparian habitats because the land is currently subsided. It's not at the appropriate elevation for creating tidal marsh or riparian habitat. However, it is part of the planned design for moving forward with Frank's tract that there will need to be actions taken to remedy that and sediment placement. And so again, this is not saying that restoration can't happen. It's just flagging that to make sure that you're aware of the potential issues. Next slide. Okay, so just to summarize what that means for Frank's tract, for all of our scenarios, we're seeing a lot of benefits. We're seeing increases in tidal freshwater, wetland, and riparian and willow riparian shrub scrub. We're not seeing any impacts on agriculture or transportation and energy infrastructure. And we do have to think about the physical suitability for our restoration actions. And then you can see there are metrics in which all three of our scenarios score the highest. For the metrics that we're looking at, scenario C has scored the highest for more of them, but that doesn't necessarily mean that it would be the scenario that users want to go with. Next slide. So thinking specifically about other considerations for Frank's tract, in the Frank's tract Futures project, scenario B was ranked by the highest, followed by C and then A. And that was due largely to a lot of metrics that aren't currently well captured by the landscape scenario planning tool. So thinking about sport fish habitat, boating access, and water quality. Brett Milligan and his students have done a lot to survey people in the Delta and find out what their priorities are for this area, and that really influenced the ranking. So some of these things like access to recreation, we're working on bringing into future modules more. But some things like doing public surveys will never be captured by the tool. So we just want to make that point that we think this is a very useful tool to help make these decisions, to help understand trade-offs, but it's certainly not all encompassing, and there are going to be other factors that need to be considered. Next slide. So just a final summary of, I guess, what I'm hoping folks will take away from this example, that the tool is really useful for understanding the potential benefits for future scenarios and for evaluating trade-offs between multiple scenarios, because it allows us to relatively quickly assess multiple different benefits. And because we're providing that historical context along with the summary of modern conditions, it really lets us put the future scenario benefits in context. But the tool's not going to identify what the best scenario is. It's just going to highlight what some of the benefits are to help the user make that decision for themselves. Not everything's going to be captured by the tool, so the user is going to have to decide how they want to use this information in combination with other input. And as we've said, we've used a modular approach to developing the tool so that we can continue to build on the tool's functionality. So we have more tools that are currently being developed, and we certainly want to hear from folks if you have thoughts about other types of analyses that would be helpful, other things that you want to see in the tool that we could try to bring into the future to make it more useful. Is there time for questions, Donna, or did I
We'll go ahead and take a couple questions. Stuart Siegel and Dawn Edwards have a couple questions that probably Lawrence can answer for basis for defining the analysis boundary and whether or not the extent of the tool extends up into YOLO bypass.
Yep. So the tool captures pretty much the entire delta, and we will be going in the future directions, which we'll end the session with. We're also extending that to soon. For Frank's tract, we just kind of narrowed it down so the maps would be a little bit more visual, because when we're blown out to the whole delta, it's kind of hard to see in such a relatively narrow area. For the Frank's tract, what defined a black line? If I'm being honest, it was somewhat arbitrary. I wanted to originally just kind of do a buffer, but it kind of cut across features a little bit weirdly. So I just kind of roughly drew a boundary around that kind of stuck to major boundary features as I saw them. It's far from perfect, but you know, again, the workspace has run it on the whole delta, so you can easily refine that ROI and just run the last output tool again.
Can I jump in on the extent of the tool, just so the history is clear? The current extent of the tool is based on where we had historical ecology study boundaries for the delta, and that was based on an elevation level. So it's basically just a certain level of elevation around the perimeter of the delta. And with our current work, we'll be extending that to the full legal delta. I also just wanted to say, to be clear, we want to thank Brett Milligan and his students and everyone else who was involved in the Frank's Tract project for providing us with those data files so that we could have this example to share here. So just wanted to acknowledge all the work that went into creating those scenarios.
And a couple of questions. Susan does have her hand up again.
Hi, I was just, this is a fantastic tool, and so my imagination is going a little wild here. But I'm wondering, would it be possible to add a module on wildlife-friendly agriculture and what those kinds of lands contribute to species survival? Is that a possibility?
I'd love to answer that, Susan. We really wanted to do that at the very beginning when we were developing the tool. We wanted it to be one of our sort of like keystone functions that in our earlier reports we talked about. And we worked pretty hard to try to find data, and there weren't great data sets out there of wildlife-friendly ag already. But I think it's exactly the kind of thing that needs to be added. And it's a great example of how there has to be a science process. It's not just as simple as plopping something into this work, you know, the programming that's already there, but there actually needs to be a science process to determine, you know, what are the kinds of wildlife-friendly ag that you're talking about? Where are the data sets? How do you pull them together and then score them in terms of, you know, how some are better than others probably at supporting wildlife. But so that would be the process, and we would love to do it. And it's just a question of thinking about how do we find the support to be able to go through that science process. Mm-hmm. That's a great idea. It's been high on my list for many years, so maybe we can talk sometime and you can help me think about how to get it done.
Yeah, I'd like that, Letitia. Thank you.
So I'm going to pause us. We are noting the questions that are in the chat that we haven't answered yet, and we will have a question and answer period, so we will bring those back out. But we do want to make sure we have time for a breakout discussion, because we really want to hear from you, like how you might use this tool, why you're interested in the tool. So we're going to have a breakout session with that. And I've been instructed to tell you all, do not press any buttons when you get a notice for a breakout session. You don't have to push join now or leave now. It will be done for you automatically. So just wait patiently, and you'll be deposited into groups, and there will be those of us from SFEI in each group to help facilitate those discussions.